Assalamualaikum warahmatullahi wabarakatuh. So now I will present my work on proof techniques and conclusion. My name is Nura Aini and let's get started. Okay, now first we'll talk about the problem and the proving of proof techniques. Okay. The first thing that we will solve in proving techniques is to prove whether there are infinitely many prime numbers. So the proof to prove that there are infinitely many prime numbers, we will use contradiction. By contradiction, we claim that the original statement is false. Then we are going to assume that the opposite is true. That is, we assume that there is a finite number of prime numbers. We say there are only n prime numbers. Let's associate them with the variable p with subscript 1, 2, 3, 4, and so on. Since the set of prime numbers is assumed to be finite, the largest prime will take the subscript of n. Listing them, we have p1, p2, p3, and so on until pn. Now we construct a new number x by multiplying all the prime numbers, then adding 1 to the product. So we got x equals to p1 times p2 times p3 times p4 and so on until times pn. Then in the end we plus 1. Actually, there are two possibilities of the value x. It can be either a prime number or a composite number. Clearly, x cannot be prime since we already assume that we have the prime which can be written as p1, p2, p3, p4, and so on until pn. That means x must be a composite number. Thus, at least one of prime numbers can evenly divide it. Let's represent all primes in a list as k, where k is greater than equals to 1 and less than equals to n. However, k doesn't divide x since we always get a remainder of 1 when we divide x by pk. This is a contradiction to the assumption that we have all the prime number in the list, which implies our list of prime numbers is incomplete. Therefore, we reject the assumption that there are finite many prime numbers, and thus conclude the original statement must be true. Then now we have just proved there are infinitely many prime numbers. Then we move to the second problem and proving. This is about proof techniques. Okay, we must prove whether this is true or not. Let n be an integer. If n squared is odd, then n is odd. We will prove it by contraposition. Suppose n is an integer. If n is even, then n squared is even. This statement is the contraposition from the statement that we need to prove. So if n squared is odd, then n is odd. If the contraposition is if n is even, then n squared is even. Then since n is an even number, we let n as to k. Right? It's even number. Then we substitute to k for n into n squared. Now we have n squared that the n we substitute with 2k, so we get 2k squared equals to 4k square. Sorry. Then factor out 2 to get 2 times 2k squared. Since k is an integer, so is 2 times 2k squared. Then substitute 2, sorry, it's wrong. We just substitute the 2k squared by some integer r. Therefore, we could get 2r, which is clearly an even number. Because everything that we times by 2, it must be an even number. So we have proved the contraposition to be true. That makes the original condition statement true as well. Hence, we have proved that if n squared is odd, then n is odd. It's proven. Then the third one about conclusion. This is about problem and answer actually. So here, Fiona is saving the rest from the rest of her allowance because she wants to buy shoes. If Fiona's saving reach $100, then Fiona buys new shoes. Fiona wants to jog every day. For that, she needs these new shoes. So if Fiona buys new shoes, then Fiona jogs every day. But after 1 month, Fiona was not jogging either. So the conclusion is, we will discuss it together. So we got the premise one is if Fiona's saving reaches $100, then Fiona buys new shoes. The premise two, if Fiona buys new shoes, then Fiona jogs every day. The premise three, Fiona doesn't jog. First, let's conclude from the premise 1 and premise 2 first. The premise 1 is P and then Q. Because Fiona's saving reaches, if Fiona's saving reaches $100, then Fiona buys new shoes. So if P, then Q. The premise 2, if Q, then R. If Fiona buys new shoes, Fiona jogs every day. With the syllogism mode syllogism, then we get the premise 4. It makes the P then R. So the conclusion from premise 1 and premise 2 is if Fiona's saving reach $100, then she jogs every day. Next, we use conclusion with premise 3 to find the final conclusion. So the premise 4 is if P, then R. But the premise 3 is not R, the negation of R. So Fiona doesn't jog. with this modest tolerance. Then we got the P5 is negation of P. So now we get the final conclusion is that Fiona's saving did not reach $100. And that's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.